alkynes, molecules that have a carbon-carbon triple bond, alkynes undergo 3 different types of hydrogenation reactions. The first one is similar to the catalytic hydrogenation of an alkene that we have already learned about. In this reaction, we will mix our alkyne with hydrogen gas and a metal catalyst, platinum, or we could use palladium, or we could use nickel, just like with an alkene. This reaction completely reduces the carbon-carbon triple bond all the way down to a carbon-carbon single bond. So the product of this reaction will have a carbon-carbon single bond and the addition of 4 total hydrogen atoms, which, if you're noticing or paying attention to the stoichiometry, that means that we are not reacting each alkyne with one H2 molecule. We are, in fact, reacting it with 2 H2 molecules, putting 4 total hydrogens. But in this particular reaction, it is very common for us to just write H2 as the reactant, not 2H2 or excess H2. And we all understand when we see these reagents combined with an alkyne, we all understand that it's going to react all the way to an alkene. Another type of hydrogenation that we can perform is also using H2 gas with a different type of catalyst known as Lindlar's catalyst. In place of Lindlar's catalyst, you could also use Ni2b. So that would be H2 gas, again with Ni2b. Now, in this particular case, we are in fact only adding 1 H2 molecule to the triple bond, which means that we will be reducing the triple bond only to a carbon-carbon double bond, putting 2 hydrogens from the H2 molecule and the R groups or whatever was already attached to the alkene. And this particular reaction always produces the cis isomer of the alkene. So the hydrogens that are added will always end up on the same side of the double bond or cis to each other in the molecule. The third type of hydrogenation is called dissolving metal. So this is right here is the dissolving metal hydrogenation. This uses sodium metal dissolved in liquefied ammonia. This reaction also converts our triple bond to a double bond, but this gives us the trans isomer. So just for your notes, let's name all of these reactions. This is catalytic hydrogenation, just like with the alkene, same name. The hydrogenation reaction that gives us the cis alkene is called poisoned catalytic hydrogenation. And the hydrogenation reaction that gives us a trans alkene is called the dissolving metal, because we're dissolving the metal sodium, dissolving metal hydrogenation. Let's look at all 3 of these different hydrogenation reactions applied to a single alkyne. So here we have this alkyne, and we've got 3 different ways in which this alkyne can be hydrogenated. Let's start with the catalytic hydrogenation first. And remember, even though the reaction implies that there's only 1 molecule of hydrogen gas involved, we know that, in fact, this reduction is going to go all the way down to an alkene. It's very important that we keep track of carbon atoms. I'm going to number the carbon atoms on this chain because it's actually very easy to lose carbon atoms when you're drawing these products or add carbon atoms. So there I've numbered it, not trying to number it IUPAC, just numbering the carbon atoms so I can keep track of them. H2 with Lindlar's catalyst. This is the reagent that gives us the cis alkene. So we are going to reduce our alkyne to a cis alkene. 1, 2, 3, 4, 5. In terms of how we draw that cis alkene, you can really draw it however you would like, as long as you are making sure that you are showing the cis orientation around the double bond. So the two structures that I've drawn here, these are actually identical to each other. This is just two different ways that you might represent the products of this reaction. And then last but not least, we have our dissolving metal. This is the one that gives us the trans alkene, which will look like this. 1, 2, 3, 4, 5. So in terms of remembering these three reactions, the catalytic hydrogenation should be pretty simple for you to remember because it is the same as what we see with an alkene. For H2 with Lindlar's catalyst versus the dissolving metal, sodium, it's a little bit harder to remember. The way that I remembered this personally when I was learning this as a student, I remembered it because the cis alkene kind of resembles the letter H, sort of in its structure. I mean, it's a bit of a stretch, but it kind of looks like the letter H, which is the H2 reagent used in this reaction. And then the trans alkene kind of, and this one's a little bit trickier, but it kind of resembles an N. I mean, that's like a backwards N. It's like a mirror image N. Sodium, this is a mirror image A. The sodium, which this is sort of, maybe looks a little bit like a Z, and or a trans shape. And this is how I remembered it when I was a student. Kind of cheesy, but it was definitely effective.